This is Nina, and this is take 4, I guess, of Quadratics on Desmos, where I was muted the first 3 times and I don't know what happened afterwards. So here we have the mother function, the basic quadratic equation. You just have x squared and f of x represents, function, like what the output is. So this gives us the average stretch compress parabola. So it's an average width of sorts, and we don't have any b or c terms, or I guess there's 0, but we don't have any variables for that, and there's no variables for h or k in the given expression, making the vertex of this parabola 0. And so yeah, so if we launch into vertex form, this is what it's going to look like. A parentheses x minus h squared. So h and k in a quadratic represent the vertex. So if the vertex is either the lowest or the highest point on a parabola. So since our a is positive, our parabola is facing upward, and the vertex is the lowest point. But if we had a negative a, then our parabola would face, our parabola would face downward, and our vertex would be the highest point, connecting the two infinite lines, or curves, I suppose. So why don't we go ahead and use the vertex form right here. So as you can see, let's disable this one. If I make my a as 1, which is the average slope, if you will, and make h0 and k0, you will see that we get the average parabola, like we did before. They overlap. So now, diving deeper, we can see that h controls how left and right the parabola goes on the graph. So since h is negative or opposite in the equation, that makes it that if you have a positive h in real life, it's going to show the opposite in the equation. So if you have x plus 2 in the equation, you'll have the x equal negative 2, since the sign is split. That was a little bit confusing, but math is confusing. So is life. So we shall continue. So as you can see, when h is positive, it moves to the right. But when h is negative, it moves to the left. Yeah, h controls how left and right it is. Moving on to k, k controls how up and down the parabola is. So as you can see, h and k come together to form your vertex on a quadratic. So if we have a k of 1.2 and an h of negative 2.4, you'll get this point right here. Moving on to a, like we said before, determines how compressed or stretched a parabola is. So if we have a greater than 1, our parabola will get steeper and steeper. But if we have an a less than 1, so 0.25 or 0.5, we will get a bowl shape. But the same thing happens when you flip the sign of the a. Yes, so if we have a negative a over 1, it'll get steeper, but it will face downward, making the vertex the highest point. If it's negative 0.5, you'll get a bowl shape, but opposite in the upside down. That's about it. What was that? The standard form for ye olde quadratic is ax squared plus bx plus c. So this doesn't tell you much when you go to graph, so I would recommend using the vertex form when sketching a quadratic, because it's way easier because you have your hk inventory, which is the vertex. Basically, from having it in standard form, you can glean where the y-intercept is, and you can also tell where the two x-intercepts are. Yes, by solving. So since x-intercepts are in the quotes parentheses, they have 0, 4 for y-intercept. You can plug in for 0, and that's your c. That made no sense, I know. But basically, your c is your y-intercept, and if you input 0 for y and you factor, then, or solve. Yeah, factors, yeah. When you solve a quadratic, you get the x-intercepts, and that helps you kind of draw out the graph, and there's also a shortcut for finding the line of symmetry. Oh yeah, quadratics have lines of symmetry. So if you were to slice it right here, they would fold, and well, if it were a piece of paper, they would overlap these two sides, like so. That's about it for real this time. Thank you for watching my Desmos demonstration. Au revoir. I don't know why that was in French. Bye bye.